Okay, do you know how to say this word right here?
No.
Okay, it's said ratio.
Ratio.
Okay, it's kind of like a fraction, but it's a little bit different. All right.
Yes.
It has this notation, these two dots right here. So we say this 2 to 3. 2 to 3. Okay? 2, 2, 3. So if I change it now here and I make it like this, 5 greens and 6 blues, how do you think you say this ratio? This ratio right here.
5
2.
to 6.
Yeah, 5 to 6. Okay?
Yeah.
Okay. So it's just saying the red to the, the green to the blue. Green to blue. Okay. Now, the thing is I can actually put this in a container. So what I'm going to do is I'm going to put this in a container. Or I can put it in 2 containers. So over here on the right, I have 2 containers. But each container has the same ratio. It has 5 of these green and 6 of these blue. Okay. And I can do that with 3 also and so forth. Okay.
Yeah.
So if I take 5 greens and 6 blues and I put them in 3 containers, then I can say total, how many greens do I have in total here?
You have 15 greens.
Yeah, and how many total blues do I have
18.
Here? 18. And remember, when we add up totals that keep repeating themselves, it's faster just to multiply, right?
Yeah.
So if I know if I have one that's got this one container right here has how many greens?
15.
One container, just one container, not all 3, just one, just this one right here.
5.
Okay, and then another one has,
5.
and then another one has another 5. So if I total them up, I have 15.
Yes.
And a quicker way to total is just to multiply, okay? And I'm always going to multiply the same number on the top of the ratio on the bottom. So a lot of times when I do calculations, I want to rewrite this ratio as a fraction because it's very easy to do calculations with, okay? So I can take this ratio of 5 to 6 and I can write it like this, okay?
Yes.
And if I multiply the top by 3, then I got to multiply the bottom by 3 because this 3 is how many containers we have. 1, 2, 3 containers. Okay? All right. So let's talk about this a little bit, okay? So let's go back and let's say now we have 3 green and only 2 blues. How do I say this ratio? This ratio
You
here.
say 3 to 2.
Yeah, this is 3 to 2, okay? And it doesn't matter how many containers I have because I'm just going to keep repeating that same ratio, the same pattern, okay? But it does change how many totals that I have. You understand that? Okay, so how many containers do I have here? How many containers do I have?
You have 6.
6. What's the ratio of one container? 1 container.
3.
2.
And 2.
3 to 2. How about for all 6? What's the ratio? Well, I got to count all these. What's the fast way to count? If I got 6 containers, yeah, 6 times 3 is right there.
18.
18. And then on the bottom, each container has 2, so 6 times 2 is
12.
okay. When I have the one container over here, are there more greens or blues?
Greens.
Okay. How about in the all sets, are there more greens than blues?
Green.
Okay. But you notice earlier when we were doing a problem, we did something similar to this, and you didn't keep the ratio when we multiplied it. Here, how many more greens are there than blues? Just in this one ratio, there's 3 greens and 2 blues. How many
One more.
One more. But every time we repeat that pattern, we're always going to have one more, one more, one more, one more. So if we had one more in one container, we had one more in one container, and then we do that 6 times, we had one more in one, how many total more greens do we have now than blue?
6.
6. What is 18 minus 12?
6.
6. So that's ratio is going to keep doing that all the way through. It's always going to keep that same number of greens and blues. So a lot of times in math, that's why when we have something like 18 over 12, we simplify it to 3 over 2. Because 18 over 12 would be like the whole set, all 6 of them. But I can simplify that down to just 3 over 2. You understand that?
Yeah.
So this is a lot of times why we simplify fractions. Yeah. You have any questions for me?
No.
Okay, good job. Thank you.
Thank you.
Yep, see you.